Okay, you're welcome. So sorry, earlier we had a connection issue, so I had to restart this video again. So maybe most of you are not online, but I will share the link with you for us to continue our project. Times life has some few difficulties, but we have to keep moving on. So today we are looking day 3, feature engineering. Remember, day 1 we scraped the data from the website. Day 2 we did exploratory data analysis to see some inconsistencies in the data. So day 3, which is today, we are now going to correct those things that we've already seen. So if you see me changing some things directly and you don't understand, then remember you have to go back to day 2 to understand. We took the whole of that session just to understand what are the things that we need to fix in this step. So that is the process. I want us to walk through this process in part 1, and then part 2 we're moving on now to other things. So let us go on then. Let me go to the page. So let me go out of here. Okay, good. Let's go here. So now let's go to our Sagemaker Studio Lab. Remember, if you don't have an account, you should you can request for it. Just click here. You can request here for an account, but I already have an account, so I'll just sign in. And again, remember, you can use Google Colab to follow through. It must not be only with the Sagemaker Studio Lab. Maybe while you're requesting for your own, it takes about 1 to 5 business days for you to have it. So just be patient if you've requested for it. And then this is Google Colab, so you can open a new notebook here and you use, or you can use Try Jupyter to follow through, or simply you can watch and then later on you try to follow with this video. So you can use all of that. Okay, so let's go straight to Sagemaker Studio Lab. So I'm going to run the start time. So let it start. Let them Sagemaker will start spinning servers for us at the back, and then we'll be able to access our project and continue from where we ended. So I stayed back and I just completed the code so that now we'll just go through, so you see all the logic of how we do feature engineering, which you can also apply in your future projects. So it's ready now. Let's go to open project, then go here. It's loading. Just close that one. Okay, so coming here, if I pull this like this, this is what we did. We did our scraper first thing. Let me go click on it. We scrape the data from that website in day 1, and then at the end of the day, which is the website, remember the website, we scrape the data there, and this is it open here. This is what we scraped. The LAN, we took out the price, the location, and the meta square. So we took out all of that, and then now that was the first thing. So we came out now, exported this CSV file, this file, land price data CSV, which is this file here. Let me double click on it. So if I open it here, this is it. So you have the prices, you have the location, and you have the area. That's what we did on day 1. Day 2, we did the exploratory data analysis. Let me click on it. So we started looking at the big picture. What if they have missing values? Analyze the distribution of the dependent variable, that's the price. Looked at area, looked at location. So when we did that last week, we realized some inconsistencies, which if you see here, you see there's really much outliers here. The data is just concentrated only here. Almost everybody is here. So we said we're going to clean that today. You see, it's not looking like a normal distribution. So we're going to clean that today. Then now we looked at the numeric figures. You see the land also, area also was too. We had too many, like 500,000 meter square. It's hectares. It's 50 hectares. This is not residential land. So we also said we have to limit it to just residential land. Maybe 1,000, 2,000, 3,000, 5,000 meter square is okay for people to build. If not, our model will not be accurate. So we might have two models, one for farmland, one for residential area. So this is also how we looked at the location. Some of them are not many, so we might have to eliminate rare locations and just focus on locations that have some at least a good number of data points that we can use to train our model. So we did all of that, and then we didn't touch the data. That is exploratory data analysis. Right now we are doing feature engineering, which is actually touching the data. So let us go now. This is it. So we are doing now feature engineering, and what will we be doing? First of all, we import our libraries as usual, our Pandas, our Seaborn, matplotlib. Then we would remove the farmlands, which we saw last time, as we saw that way that the farmlands are disturbing, are really a hindrance to our figures. People don't buy 500,000 meters square to stay on, to build on, and stay for their own residential purposes. If not, they are really outliers. We remove cities too. Like we notice that cities like Douala and Yaoundé in my country, Cameroon, if you are from Cameroon, you will know because it's real data that we scrape. But then just imagine if you're not from Cameroon, like we are trying to do analysis of maybe per country, like life expectancy in countries. And then in the same data set, we have life expectancies in continents. Like we want to look at life expectancies in United Kingdom or Germany, then we are seeing life expectancies in Europe. So we have to remove Europe because it's not a country. So that is why we are going to remove the two cities, Douala, Yaoundé. And then we also have to correct the price inconsistencies that we noticed. The fact that some people were entering prices instead of, say, putting here, this is not really a good example, and you see, for example, 1 meter square, and when you come maybe down here, you see it's 108 hectares. So these are small things in real life. That data is messy. So 8,500 then hectares. So really messy. It's not easy. And if you come out here again to talk about the pricing consistencies, you see maybe something like this. For example, this is really high for Cameroon. We have a dollar is about 500. We have like 500 francs per dollar. So this is like maybe is it 50,000, per square meter. So the problem is that the person did not divide. If we divide this 700 meters square by this 26 million, we will get the right amount. So the person instead just multiplied it and didn't put the price per meter square here, but just put the total value of the land. That is the price per meter square times the total number of meter square. So just imagine if this was, say, 1,000, for example, then it means the actual price per meter square is 26,600, which is reasonable, which is logical. So that is something that we are trying to clean here, the price inconsistency. And then we are coming here to say we need to split now the data into the train and the test data set, so that we can be able to train, learn, the model will learn from the train, and then we can use the test to validate if the model can perform well out of data that it has not seen. Then we also want to look at missing values. Now that we've split them, we need to see how do we handle missing values. Should we replace them by mean? Should we replace them by the median? Should we delete them? What should we do? We need to look at. Now we also need to look at the outliers. Are there some outliers that you might need to take maybe some logs or some maybe square root or whatever? You need to check what do I do? Do I need to delete the outliers, or do I need to maybe do some capping above maybe 99%? We either just keep them at that, or we remove them, or below 1% we keep them at that. That's the extremes. We need to decide. Or is it how many standard deviation away from the normal? We need to decide. Then we have categorical variables. There are so many. We saw that we had about 160 or more locations. We cannot use all of that. And besides, not all locations are, we need to focus on the popular locations, so that our model will be focused and say I'm only dealing with maybe top 20 or top 30 most demanded locations. If not, we will not get anything from it. So we need to be able to reduce that and separate them to the most popular and the least popular. Then we export to a CSV file to prepare now for next week, where we are going to put now this in the standard Sagemaker on live AWS, and then we put it live where it can scale to millions of users with no problem. So now let's move on then. So this is what is happening. The first, we said we import the libraries. So we import normally our Numpy as NP, import Pandas as PD, then import matplotlib, just the pipe and plot part of it, as PLT, and then we import Seaborn as SNS. This you already know. If you don't, then just look at the previous videos. And then this one, we use this line just to inform that we want the plots to be plotted inside here, just for the Jupyter notebook. So you always just need to use this so that your plots stay in here. So now, first thing, we always have to load the data set. That's why we are trying to read our CSV file, which is this file here. So let me reduce this. So we are trying to read our CSV file, and then now we are saying index column is 0. So let me run this, and if, for example, I didn't put this, I'll just Control X cut. When I don't put that and I run it, you see I get this index here. It's unnamed here because it is taking it like index is coming again twice. So for you to eliminate that, that is why you run this here. You put it here, and then when I run it now, you see it's disappeared. So let's move on. So you see you have 4,490 rows and 3 columns. Good. So I didn't scrape much, and we don't want to scrape much so that we don't stress the resources of the website we are scraping from. This is just for education purpose. So please be gentle with the website. Try to respect the robot.txt file. So now you have the data set described. You run this just to see your numeric variables. I see price here, 4,490, which is what we saw here, but area 4,270, which is less than this one. So they are missing values. Remember, we have to check missing values ahead. Then we look at price. What is the average price? The average here is really so high, while the median is really low compared to this. So it means it is really skewed. If you see, maximum value here is really high. So I think something like 450 million or so per meter square. No, it still comes down to that problem of pricing consistency that we noticed here. So we look at area, we see that 50% of the people bought land for 1,000 meters square, which is logical. Residential area is not supposed to be too big, but we see there are some outliers here. 500,000 meters square, this is like 50 hectares. These are farmlands, which we said we are going to eliminate. So let's move on then. So we start by removing the farmlands. So when we do a plot, we see that most of it is here, so we need to cut somewhere around here so that we leave out all of these, which are farmlands. Maybe we can have a separate model for farmland prediction only, but for now we are on residential land prediction. So we create our data set now would be with just less than 5,000 area. The meter square, we don't want any meter square above 5,000. So we've done our cutoff, and then when we run again our data set.describe, I think I'll just be running them so that if we go down and we need to run something, I'll just press shift enter, shift enter, shift enter, shift enter. So if we need to run something down there, I'll run it and we'll see how it goes. So that's how it is. So we look at this .describe. So now look at, there's something interesting here. The area is now, there's no missing value. There is 3,072 for price, and there's 3,072 for area. So you see those farmlands were even the ones causing the trouble for missing value. So which means normally down the line we should not have any missing value again, which is good. So just that one move has solved us that problem. So let's move on then. I'm going to go here. Then we are now trying to plot a new area, so it looks kind of a bit better now at 5,000 here. So we see most people are buying land below the 1,000 this area. So you see this is logical for people to build. So that's okay. It looks okay, even though we know there might still be some farmlands here. But then let us move on then. So now we go to removing cities, Douala and Yaoundé. So I just wrote this code, which is saying filter out, because remember this, you are saying that where data set the location is not equal to Douala and dataset.location is not equal to Yaoundé. So we are subsetting all of that. So every other thing that is not Douala and not Yaoundé, we update our dataset to the new dataset. So we now have, in fact, here we're just taking off Douala and Yaoundé because those are the cities. Remember, it's like you're comparing per country, then you have Europe or you have Africa again here. So we want to take off the whole big and all is because the data was not maybe well entered where our scraper was to scrape the name here, which is supposed to be Blendi. Somebody might put, say Blendi is in Douala, might put Douala here. Then it's instead down at the description here that it comes to maybe specify. So this will really be some unstructured text that we might end up scraping this using NLP, natural language programming, to be able to extract the real data in some of these. But then let's just move on. We are still in part 1. Hope part 2 will get into more complicated stuff in our Sagemaker series. So then let's move on then. So now the next thing is we are looking at we want to correct the price inconsistency, which we have noticed again, like this one that we just saw here. So we are trying to say, if we see things like these, we should divide them by 7 by their area and consider the new price, that the divided price should be the new price, because this price is not logical at all. It's, as I said, human error. So if you see this, you divide it by the area. So let's go on here. So that is where we have this line here, which is saying dataset group by price first. This is something that you might need to look at the group by function to understand it, and you might remember how we do the floor division. So we are like doing the floor division to be able to like kind of wipe out somehow this anything below 1 million, so that they all look like one line 0. So it's like we are creating intervals of 1 million, 1 million each. By doing this divided by 1 million times 1 million, is like we are doing some binning. So we are like creating new intervals, discretizing a continuous variable, so that we have discrete intervals of 0 to 99999.99, 1 million to 2 million to 3 million, 4 million, 5 million, 6 million. So you see how we have these outliers here. So we see that most of the data is below 1 million here. So which makes us to say, okay, we could come and say, set a new price condition, which says that if any price is above 1 million, then we should divide that price by the area, just like this one, divide that price by the area, and that should be the new price 2. Otherwise, if it is below 1 million, we should just take the price as it is. Of course, there will be some that will pass below 1 million, which were supposed to be divided, but most of them above 1 million, most of them, sure, we really had to divide, because it is really, the outliers are mostly on the right side. It is positively skewed. So now let us go here. Let me run. I think I stopped running somewhere up here. Let me run them again. So let me run. So that when we reach down there, we should be able to do the same thing. So now let us go to splitting of the data. So we want to split this data. We will now use sklearn.model selection, and then we import the train test split. So we are trying to split into two, the train set and the test set. So we call train test split, and then we say, take that data set, split it, give, this one is 0.2, give 0.8 to the train set and 0.2 to the test set. So this 0.2 is 20% of the data should be on this side, 80% of the data should be on this side, and then we put a random state so that we just make it to be such a way that when you run this code, if I run this code several times again, it will still be the same because it is random. So let me see. Okay, it's not defined because I'm not running it. Let me run it first. Then we run it. Okay, it's fine now. So we check our test set. We see that we have 554 rows. Then we check our train set. Let's check our train set. our train set. So we see down here that we have 2,216 rows. So that looks okay. Now let us move on then. We want to go to handling missing values. So we run this code which tells us if there are missing values. Again, we knew already that there will be no missing values. So this is also so you keep the flow and you know that these are the procedures that we follow. Today we don't have missing values. That's good news. So let's move on then. Now we go to handling outliers. So you say we want to see we group this train set dot price dot size. We plot it. So we see that okay, there are some outliers here, and if for example we plot them like this with log, we took log np.log, so we call numpy for help because it's good with computational things, and say give us the log of these things and plot, and let's see. We suspect that is a log normal distribution because log normal distribution, it is skewed to the right. Remember your statistics. That's why we talk about statistics in data analysis. So now we are here saying okay, let's take logs and see. And if you take logs and you see that your distribution looks normal, then you conclude that the original distribution was log normal. So we have concluded that yes, we are right. Our distribution was a log normal distribution. This is some revision of statistics that maybe you need to do, but for now, understand that we'll be taking logs. Logs help us also when we'll be doing the prediction to fasten the speed of the training of the machine learning model. Without logs, some models can still work, like the decision tree, XGBoost, but then you need to take logs at times when you just want to speed up the process, at least for those ones. And then for other models, you must take logs. If not, it will not be able to work. So let's move on then. So now the next thing now is to create now this log actually like a new part of the data set. So remember, Pandas is going to give us a warning that we are trying to create a value is trying to be set on a copy of a slice, or this is just warning you that careful, you have not made like a copy a part of it. So you're changing the original data set. There's no problem with that. That's what we want. So we want to change it. We are on feature engineering, no longer exploratory data analysis. So we change things as we move along. So let's run this now and see. So we see this is like this. So now we have our new log prices. We have the first price. We have the price with the division. When you are above a certain value, they divide and they correct it for you. Then we take the log so that it looks normal and our machine learning model will run faster. So there we are. We move on now to the last stage before exporting the data, which is handling now categorical variables. So this now we look at the location. So we say okay, there are some locations that are many, like Yasa appears 176 times, so it means people are buying. There's lots of trading going on here. Then there are some that are maybe Mokolo, Elik Esono, Esomba, Newport, Newtown, Airport. So they are just occurring once. So we need to find a way to divide maybe this 176 divided by the total to see the percentage, so that we know that people who are rare will be having 0.0000 something. They will not really be found. They will not take a good proportion of occupy a good proportion of the total number of rows here. So we should focus on the popular cities. That will help us also be able to have our machine learning model run faster, be able to build. We will not have sparse data, because the curse of dimensionality is that you have many columns. If we do one hot encoding, which is what we are going to do, each of these will take a column. Yes, I'll be a new column. Odds will be a new column. Log base will be a new column. Ones and zeros. The thing will be so wide, while we just have a small data set of 2,000 rows. So that's not cool. So that's why we have no choice but to go for the popular location. So how do we do that? We create let me take this off so you see. So we are going to take location, and then we just do a group by, pass through a group by to be able to say count the number of times that you have a specific location like PK or Mokolo divided by the total length of the data set, that is the 2022. Let's just run this and see. So you see some sites are 0.01 times. So if we put it in percentage, it will be like 1.1%. This will be like 0.9%. This one will be like 0.3%. This one will be like 0.1%. So we can also, if we can also just sort, even sort values. So let me go back here. Okay, no, let's move on. So I'll do that down here. So now let me put it back here as it was. Look, we run it, do that down there. So when we run it now, we've created this this data set, this data here. We've created this, so we can decide now to say, okay, if we go with the location list, we are trying, let me show you what we are doing here. We are trying to filter out those that are above 1%, that is 0.01, just like we saw up there. So with the objective that when we do that now, we should be able to have only those who have above 0.01, that is 0.0, like this. You see 0.7. So if you see down here, this is the smallest. So if we increase that threshold, we'll have more. So if, for example, we say only, let me run this. So if we say, for example, only those who are 10% and above, you will see. So we don't have much there. So let's just say only those who are let's add the zeros again, run it. So let's add the zeros, then we run this here, call this here. So that's what we have. So now you see we have more. And if we go down here, for example, down here, we have more, 136 of them. So that's why we have to put a cutoff like maybe 1%. And then when we check here, you see we have, like, we can take the length, to see. So let's take the length, so there are 24 of them. Okay, it's not that bad. We'll go with the 24. So you see, you could increase, you could decrease the threshold based on what you have. So now these are the most popular. And then now what we are going to do now here is we are trying to create now another location 2, which says that where the location is in this list here, that's this filtered list, this list of the top 25 most popular. If the location is in that list, then now keep it as it is, return the location. If not, say that this is a rare Cartier. So this is an example of a rare Cartier. This is what we are trying to do simply. So we run that. Again, Pandas is going to complain that we are trying to change things. It's trying to set a copy of slides. It's no problem. That's what we want. We are on feature engineering, not exploratory data analysis. And then when we run this now, what do we get? We get now this new location. So you see some are rare Cartier like this Aqua. You come here, rare Cartier like this Mesasi, rare Cartier like Olembe. So, but the other ones are there, popular. So we have reduced. That's very good. That's what we wanted. So now let us see now what we are doing here. I will take off this one. So we are now trying to do now one-hot encoding. So let me run it, and then you see. So what do you see? We are now because our machine learning is not able to read them like this as they were before. So we've pivoted, changed them the other way so that the cities are now like this. So when you see 1 here, it means that it's away. Wherever you see 1 in front of somebody, it means that it is that city. So if you come here, you see 1 here, it means it's Limbe. So the machine learning model is going to read like this. So we now have this. So we need now to go and add this to our original data set so that our data set will be, there is some price, some meta square, and it is from Limbe. The rest is 000. Then the machine learning model will be able to understand that. So let me put back this so that we store it in this location category, and this is location category that will go now and merge here. This is the location category here. So we are merging it now with the train set. So we take our original train set and then we merge this one. So let me run it and let's see. Then I call the train set here. So we'll see what we get. So we run it. We see that what do we get? We get now a complete data set which says at this level of price of 25, you see the location is called full. Let's take this one away, for example. At this level of price of 15,000, the location is away. That's the first location. The area is 266. Then we check the price too. It's okay. The price looks okay. Then we took the log of the price 9.6, and the location 2 is still away. It's a popular site. It's not a rare Cartier. And then now this our encoding has seen it as 1. So which means that we don't need again this location 2. We don't need again this location 1, and then even price and this price. So all we need now for a new data set to be ready to get into the machine learning model would be, give me the area, give me the log, price log, and then the rest of these locations like that. So that's what we are doing now in the next step, which is dropping. We are drop this price up here, drop this price, drop the next price, drop the next price, drop the next location, drop location. We don't need it anymore. We already can get it from up here. Then also drop the second location, which is also we don't need them because we can get them from up here. And of course the axis is 1 because you're saying that it's a column. 0 is for rows, 1 is for columns. So when we run this now, we can do the train set, check out and see. Okay, let me go back here because I've already done the drop, so it's not taking the drop again. Let me go on another line and run the train set there, train set. So you see we have our train set which is ready now, which says area is 500. Again, let's come to this one here, away, or even another one, Kribi. So area is 3000. The log price, which is what the machine learning model will see, is 8. Then when we want to get the result, next session we'll convert it back using exponent. You know, the opposite of log is exponent. We bring it back to what we can understand, 8, and then also it is Kribi. So this is what the machine learning model wants. This data is clean and ready for the next step, which is deploying, putting it now in Sagemaker and deploying it live in the cloud. So you're now just ready now to export it. So we are just going to take the data set, train set, export it to a CSV file, and then we do this is the name of the new file that we want to give it. We want to call it train_clean.csv, and then we want to take away index equals to false. Remember the index we had in the beginning here when we did this. Remember when we did index call equals to 0 at the beginning, there were this index that were giving us some trouble, like this index here. So we are taking it off now with that line. So let me go back there. And then if we go back down here, we see that when we run this, let me run it. You see it creates a new file here, 2 minutes. So it creates this new file. Let me open up the file. So if I open up the file now, it's the same. It's what we've been doing. Area, look at our away again. Area 266, away 1. Then the rest of it is right up to the rare Cartier is there. So this one is a rare, one is a rare, this one is a rare, this one is a rare. So most of the rare will know that they will not be accurate because they are just dumping them in one place. So it's good. So we are ready for the next set, which is deploying our model. So I'll just go back briefly again over one last time so that we glue everything together, and then the next thing will be us meeting next time now for our deployment. So we imported the libraries, we imported the libraries. Let me go back. So we imported the libraries here, for heroes for data analysis. Then we looked at the data set just to see how it looks like. And then here, yeah, we still looked at the data set described just to see some statistics. Then we looked at the farmland and removed the farmland. So reduced from above above 5,000, we removed them. So this is what we did here. Then now we looked at them again. We saw that there were no missing values, which is good. So some of those farmlands were causing us missing values. And then when we plot this again, we should know that the problem here is just that since we've changed the data set already, these former charts are responding. Before it was not like this, so it changes because we've already updated the data set. So don't be, if you go back to the video, you see how it was originally. Then we remove the two cities, which is removing Douala and Yaoundé, because they are cities, but we want to get by the quartiers inside the cities. And then now we also corrected the price inconsistency. We try to see where can we cut off. Estimating around 1 million would be good. So we used 1 million to be the cutoff. Above 1 million, we divide by area to correct the fact that some people were entering price per meter square, while others were entering the total price or the total sales value of the land. So we now brought in our friend sklearn to help to bring train test split, so that we can have a random split of our data sets into 0.2 or 20% going to the test set, 80% going to the train set, which is what we did here. And then also we normally, after that, you should look at missing values. Our models don't like missing values, but luckily we have none. Then we try to look at the outliers. Price on prices is log normal. It's really positively skewed. So we try to look at that. And then we realize that if we take logs and plot, it will be better. It will look like a normal distribution, which is what we want. And also logs will also help us speed up the training process. You could leave it out if you was to be using XGBoost, decision trees, those kind of things like random forest. But then let us take the logs, because we also want the model to be faster, and you also see how the log normal comes up. Then when we have the answer, we'll change them back to exponential. Use exponential to bring them back to the figures that we can understand easily. Now we are changing the log. We're changing it here, and then now here, that changing the log, actually we see now that we have log prices. We have now many things now, and we are good. So we do the last thing, which is handling the categorical variables. We know that there are so many, and we saw even from last time that we cannot take all. Something like price Mokolo is just one. It could be one of those erroneous prices, so we cannot depend on just a few entries. We should depend on many entries to draw our conclusion. So we take just the popular site. So it means our app will just be focused on predicting prices for the popular sites, not for every neighborhood. So we create now that thing. This what we are trying to create here is this whole thing of every location should have its own what is the proportion of the data set it occupies. So when we do that now, we are able also to filter out a cutoff point of 1%. Anybody appearing below 1%, any city below, any location below 1% is not considered, is rare. We'll keep it aside. So these are the popular locations. So you can see here, popular location. This is where all the buying and selling is going through. And then we also looked at the fact now that, okay, we need to create a second location column, which takes into consideration the fact that if this location, the location in this train set is found in this popular list, keep it as it is like this, else tell us that it's a rare quartier. So when we'll be able to, that's when we'll be able to filter what the rare quartier is. Pandas will complain that we are trying to change things, but we ignore that. And then now you see here rare quartiers, good ones, rare, good, rare, good. So we have already enough data, the machine learning model. So the next thing now is to do now one hot encoding. And remember here I'm dropping first also true. This is important because when you have, if it's going to give you the same number of columns, let's say you have two columns, you have male and female, you have two columns male, next column female, it will be 1 for male. When it's female, is 1 for female. So but if you just drop off the female, you just have male, either is 1 for male, 0 for female, still on one column. So we just drop one of the columns. So any column that is 0 0 0, it means that it is nothing else except that column that was dropped. So that's just a good way to do your one-hot coding. And then you see we have the whole thing here. Now the next thing now is just to now I drop this, but then I try to drop again before training the data set. So this is where we normally drop all the things that are available that we don't need. Price 2, location 2. They were just transition. We're just creating them just to get to the destination of where we want this to be. And where we want this to be is to have area, have log prices, and then the one-hot encoded locations. So then we exported now to a CSV file, which is this our train clean CSV file. So that is good for the train set. What you need to try to do now is to do the same thing for the test set. Remember we did the split here. So I've gone to Exploratory Data Analysis instead. Let me go back to my my file here. So remember where we did the split. The task is to try to go back and then do it on the test set. So remember, this is the train set. There is also the test set. So you do the test set, do the same thing, go through the same procedure of checking missing values. I'm sure there's none. We saw that there's none. Handling the outliers for the test set, handling the categorical variables. Make sure the same categories used on the test on the train are the same you use on the test set. Then also you will now do all the log. You do everything just the same, and then you have also on the test set a similar database like this. So that is what we do, so that next week when we come, we just go and then we start doing our predictions on Sagemaker, the original Sagemaker, and then we are able to go live and test our model live on a live endpoint in Sagemaker, the original Sagemaker. So thank you and hope to see you next week.